Hello, AP Calculus. We've got the first lesson from the new chapter. It's this thing called implicit differentiation. So in order to explain implicit differentiation, I have to talk about what we've been doing since day 1 of chapter 3. What we've been doing is called explicit differentiation. I just never called it that. That'd basically be like if we had a function. Let's say y cubed plus 3x squared minus 2x plus 1 equals 0. So let's say I gave you guys a function where y wasn't by itself, which it generally is, right? Usually it's f of x equals a function, find f prime. Y equals a function, find y prime. Well, if you were going to do explicit differentiation on this basically just means get y by itself, then take the derivative. So in this case, you'd want to isolate y cubed, so move everybody to the opposite side of the equation. So subtract 3x squared, add 2x to both sides, and subtract 1. Okay? Then you should take the cube root of both sides. The cube root and cube cancel. And I can rewrite this as the expression to the 1/3 power. So yeah, now to explicitly take the derivative, I've got y by itself, and I can do y prime on both sides, which means take the 1/3 down, rewrite the middle, take 1 away from 1/3, and then multiply by the derivative inside using chain rule. So that'd be times negative 6x plus 2. So then that would be negative 6x plus 2 divided by 3, this function to the 2/3 power. And that would be us taking the derivative explicitly. Okay? That's explicit differentiation. What I'm going to introduce you guys today is something called implicit, which means we are not going to get y by itself and then take the derivative. What we're going to do is we're going to take the equation as is and then just instantly take the derivative with respect to a variable. So you notice, when I took the derivative over here, I had to actually take the derivative with respect to x. All right? And y prime is the same as dy dx. So that's all I'm going to do over here, is I'm going to say, let's take the derivative with respect to x of all parts of this equation. Okay? So this is what it looks like. To take the derivative of y cubed, I almost treat this like it's chain rule. Here's what I mean by that. You bring the 3 down, you rewrite the middle, you take 1 away from the power, and this is probably going to be the most confusing thing by just simply watching this video and not being able to ask me questions. Now I take the derivative of the inside with respect to x. So the derivative of y with respect to x can be written as dy dx, which is our derivative. That's the thing that's kind of the thing we isolated when we did explicit differentiation. Now, you can think about it like this. If I take the derivative of 3x squared, the 2 comes down, and you have 6x to the 1 power. If you ask yourself, well, let's do chain rule again to this thing, the derivative of x, okay, with respect to x is just 1. And it'll always be 1. So you don't have to put a dx on this. If the variable matches what you're taking the derivative with respect to, there's no dx kind of byproduct from this procedure. So then you can just do, hey, what's the derivative of negative 2x with respect to x? It's just going to be negative 2. What's the derivative of 1 with respect to x? It's just 0. What's the derivative of 0 with respect to x? That's 0. And then what you can do is you can say, get dy dx by itself, okay? So, plus 2 minus 6x so 2 minus 6x, and then divide both sides by 3y squared. And what you have here is a completely different version of the derivative down here. This derivative says, hey, if all you got are x's, I got you covered down here. But this function says, hey, we can make things a lot simpler than something to the 2/3 power in the denominator and just say, hey, this is 2 minus 6x over 3y squared. And you can compute that if you have both the x and the y coordinates for that derivative. So, I don't know if this video does justice the explanation for implicit differentiation, but the bottom line is the big difference now is that you don't have to have things nice and tidy before you take the derivative. You can just straight up say, I've got an equation, let's find the derivative, and then get that dy dx by itself. All right. I'm going to stop the video there. In my next one, I'm just going to do a series of examples. Hopefully that at least allows you to get the conversation started so that tomorrow, hopefully you've gone through a few of the homework problems and hopefully you guys understand a little bit of it. It's time to stop the video.